You know that feeling, right? You send a job to your 3D printer, and then you just wait for hours, sometimes for days. Well, get this. A technology unveiled in early 2026 just throws that entire waiting game out the window. Let's dig into how it's about to change, well, pretty much everything.
0.6 seconds. Let that sink in. That is literally less time than it takes you to blink. And that is the new world record for making a complex 3D object from scratch. We're not talking about a small improvement here. This is a quantum leap. It's a whole new ballgame for 3D printing.
Just pause for a second and really think about that. What would it actually mean if creating physical objects wasn't about patience anymore, but about something that happens almost instantly? That's the huge question this new tech is forcing all of us to ask.
So here's our roadmap. First, we'll talk about the big problem with the old way of printing. Then we'll introduce the amazing new solution called Dish. We'll unpack how the magic behind it actually works, see what it can do already, and then look ahead to what this means for the future of making things.
Okay, so let's set the scene. It's February 2026, and a paper drops from researchers at Tsinghua University that just blows everyone away. But to really get why it's such a big deal, we have to start with the fundamental problem, the major bottleneck that they were trying to smash through. Here's the bottom line. Almost every 3D printer you've ever seen works by building an object one thin layer at a time. It's painstakingly slow, it creates weak points between those layers, and you're always limited by how fast a physical part can move back and forth. But now, look at the right. This is the new way, volumetric printing. Forget layers. It creates the entire object all at once, from a pool of liquid to a solid thing instantly. And that brings us to the hero of our story. This is the technique that finally cracked the code on making true, high-speed volumetric printing a reality. It's called Dish. Now, the full name is a bit of a mouthful. Digital Incoherent Synthesis of Holographic Light Fields. But the core idea is actually beautiful and simple. It uses super precisely shaped fields of light, you can think of them like 3D holograms, to cure a liquid resin into a solid. And the really key part? The vat of resin stays perfectly still, which, it turns out, solves a ton of problems.
So how in the world does Dish pull off this seemingly impossible trick? Well, the secret sauce is this brilliantly engineered optical system. It really all comes down to 4 key steps.
Okay, here's how it goes down. First, the resin just sits there, totally still, no movement. That's critical. Then, a super fast periscope spins around it, projecting light from every angle imaginable. But it's not just any light. These are meticulously calculated holographic fields, and they act like a programmable 3D chisel. The light only solidifies the resin where it needs to, and then, bam! The whole thing cures in a single flash in less than a second.
Now that's the theory, and it sounds amazing, but what about the results? This is where it gets really, really exciting. Let's look at the actual performance and some of the things they've already made with this. This table just says it all. I mean, look at the jump. The previous record for this kind of printing was tens of seconds. Dish does it in under 1. Resolution in other systems was always a trade-off with motion, but here it's a uniform, incredibly sharp 19 micrometers. It can even work with these super thin, low-viscosity resins that were impossible before, because the object gets created so fast it doesn't even have time to deform.
Check this out. This is a perfect example of what's possible. It's a complex network that looks just like blood vessels, and it was printed in a biocompatible material. Can you imagine printing custom tissue scaffolds for a patient, on demand in a hospital, in less than a second? That's a game changer.
And just look at the detail here. This incredible little conch shell shows off just how precise the system is. We're talking features as small as 12 micrometers. That's about 1/10 the width of a human hair. Getting that kind of detail, at this kind of speed, it was completely unthinkable until now. And here we are, right back to that jaw-dropping number. This incredibly detailed miniature statue went from a pool of liquid resin to a solid object in just 0.6 seconds. It's just a stunning display of creating real complexity at pretty much the speed of light.
So, what's the big takeaway here? Why does this matter so much? Well, the applications are just massive. We're talking about personalized medical implants printed in moments, rapid prototyping of microscopic lab-on-a-chip devices, or even printing a replacement part instantly in an emergency situation. The list just goes on and on.
Okay, so this tech is clearly a massive leap forward. But, with any major breakthrough, there are still some challenges to figure out before we see this kind of printer in every workshop.
Right now, the technique is really focused on smaller things. To scale it up to print, say, a whole sneaker or a car part, that's going to require more powerful lasers and really smart ways to manage all the heat that generates. And of course, while it's amazing with these special photopolymers, the holy grail is to get this speed working with things like metals and ceramics.
But let's not get bogged down in the challenges. Let's focus on the achievement. I think the journal Nature put it perfectly. This work doesn't just improve on the old ways. It fundamentally redefines the limits of what we all thought was even possible.
And really, that just leads us to one final, kind of mind-bending thought. A technology like this brings us one step closer to a world where making something happens at the speed of thought. So the real question we want to leave you with is this: if that barrier of time was just gone, what would you create?